Hello everybody. In this video I want to talk about a very important concept for MCAT Chemistry and Physics section. So the question asks, an electron drops from an excited state to its ground state, emitting a photon of wavelength 400 nanometers. What is the total energy change if 1 mole of such photons is emitted? And we are given some constants. You have the Planck's constant, you have the speed of light, and you have the Avogadro's number. Before doing any math for all chemistry and physics questions, I like to first eliminate some of my answer choices. I think that's one of the most helpful MCAT tips I can give you, and that's one of the main reasons I was able to score 132 for this section. Answer choice elimination before doing any math. Okay? So here it says that what is the total energy change if 1 mole of such photons is emitted? So 1 mole of such photons, and we know that 1 mole of anything can be a very large number, because if you want to find 1 mole of anything, you need to multiply that by the Avogadro's number, right? And Avogadro's number is a huge number, 6 multiplied by 10 to the power of 23. That's a huge number. So going back to our answer choices, we can see that two of them are very small. Number 1 and number 3. These are extremely small numbers. But 2 and 4 are not that small. So always when you're answering MCAT questions, look for trends. Look which answer choices look different, and ask yourself why they look different. So 1 and 3 are very small, very, very small. So I'm already more inclined towards answer choices 2 and 4, because 1 and 3 are very small to be even associated with the Avogadro's number, with 1 mole of anything. But before completely eliminating 1 and 3, let's do some math. Okay? So you might be familiar with this equation right here, which is the energy of 1 photon. And so here basically the first step would be finding out the energy of 1 photon. And h is the Planck's constant, c is the speed of light, and this is the wavelength. And we have all these numbers. This is the wavelength, this is the Planck's constant, and this is the speed of light. So we just do the math, and we get this very small number. And this is a very small number because it's the energy emitted by just 1 photon. And that's why I was planning on eliminating 1 and 3, because these are the types of numbers you would get for just 1 photon. But we are looking for 1 mole, which is a huge number. So 1 and 3 already eliminated. 2 and 4. Okay, so now that we have the energy emitted for 1 photon, we simply need to multiply that by the Avogadro's number, and we are gonna get the total energy. So this is the correct answer, and this is number 2. And just a quick tip when you are doing the maths. When you are doing the maths, never try to write down everything and do every single calculation on the paper. Do not do that, because it's going to be too time consuming. Just try to do some mental math. Okay? So, for instance, for this last step, don't do that like on a paper, because you know that this number can be basically viewed as 5, right? 4.97, that's basically 5. And this is basically 6. And you hopefully know that 6 multiplied by 5 is 30. So we know that the final answer should be close to number 30 or 3 or something like that, right? So if we come here we can tell that among our reasonably large numbers, not 1 and 3, but 2 and 4, the only one that's close to 3 is the second answer choice. So we don't even need to do the math, right? Just think about the final number, how it should look like. And you can tell that it should be close to 3, and you just choose the second answer choice. Hopefully this video helped you to first learn how to eliminate your answer choices. Hopefully it taught you how to use this formula, and hopefully it taught you how to do quicker calculations. Thank you very much for watching this video. Please don't forget to like and subscribe so you can see more of these videos.